Hey everybody, this is Larry. This is day 14 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. I am actually kind of in pain right now, I'm not gonna lie. I did some sports things and then I pulled my hamstring. So yeah, I am eating again, so that part is good. And it seems like I've been eaten by mosquitoes as well, so that part is less good. So there's a lot of eating going on, but yeah. So we'll see how that goes. I haven't started the painkiller stuff yet, but we'll see. Anyway, today's problem is to 15 cave largest element in an array. So there are a couple of ways you can do this one for sure. This is literally just called quick select, which has degenerate cases of just being linear. You can obviously just sort it over n log n. There's also a heap solution as well. You heapify it, and then that's n log k. There are a couple of things like this. It depends on what you want to do with the data, or the thing, right? Yeah, and I think technically, I guess if this is one off, quick select will probably be pretty okay. And then there's some like conversation about cave as the percentile and stuff like that, which I'm not going to get into. But there are definitely a lot of ways you can think about this one, and it really depends on what you want to do with the data afterwards. And like, is just getting the cave number good enough, or do you have to do it like some other way, or whatever, right? So yeah. And I don't know if you count quick select as sorting, but I don't know. But yeah, the sorting part would have been very straightforward as n log n. So yeah. What do I want to do today? With all that said, yeah, let's play around with quick select. I guess haven't done that in a while. So yeah. Right. So now the way that I think about it, I actually haven't done this in a while, or like I don't think ever. Maybe like when I was starting out and like just trying something, but I don't remember the last time I've done this. So that we'll see how I kind of get to it, I suppose. Okay, so then you have left and right, right? Let's see. Maybe I'll do the same idea that I have with binary search, though I don't know that this is, but yeah. But basically now we take a pivot, right? Pivot is equal to, say, num sub left, because we're just pivoting left and right, right? I guess the only tricky thing is that it takes, I mean, of course, there are also a lot of literature about how and what and, the math around different pivot. I'm just keeping it stupid simple for now, and just take the first element, right? So, there is an in-place thing, but it is definitely very tricky to do it in place. So I don't know if I'm trying to think whether I want to do it in place and is it worth the effort? Maybe not. So because basically then, oh yeah, I guess another way you can do it is binary search on the answer, of course, but but that's also n log n, right? It's not sorting, but but that is constant space, so maybe that's good depending on what you're trying to do it. Like I said. Okay. Yeah, yeah, okay, so do I want to write it this way? Let's just write it. How do I want to write it? Alright, so let's do a do while loop, which in Python is a little bit weird, but right, so left. So now let's just say we have a current array. Right, this is current. And now we have a left and we have a right. And then now pivot is going to be equal to, let's just say the first element in current, right? So maybe this is while length of current is greater than 1 or something like this, right? And then now, yeah, and then it's just for x in current, if x is greater than or equal to, I forget how the exact phrasing is, to be honest. I mean, you could also not use the pivot, but that may be a little bit weird if you have non-distinct numbers. So yeah, so let's just say if this is this, then we have it on the right, else we have it on the left, right? Then now we just have to check if length of left is less than or equal to k. Is that right? I'm just thinking about off by ones. So if k is k 0 indexed or 1 indexed? Let's see. So k is the largest. I might have mixed this up a little bit, but either way I'm thinking. So 2 is so this is 1 indexed. Okay, yeah. So that means that the largest number. So let's see. I forgot that is biggest. So all right. So if we're on the right side. If length of right is greater than or equal to k, then that means that current is equal to, let's just copy it from right, and then else current is equal to left. But maybe we don't even need to do a copy like this, because I just, but just keep in mind that the space actually could be a little bit at least the way that I'm doing it now is very expensive. It could be n squared, depending on how you want to count it. But yeah, and then now, so if this is on the right side, this is good. Otherwise, then k we right, something like this, and then now we should only have one element, so then we can just return 0. We'll see if this is quite right. I'm not convinced, to be honest. And it may infinite loop because I have something silly where quick select is not something that I do that at all, even really. I don't, like I said, I don't remember the last time we did. Let's see. If k is 1, then it will be on this side. Oh, this is so. Oh yeah, so then we have to get rid of the period, I think. Because otherwise, this is obviously infinite, because it just keeps on picking itself as the period, because I've been lazy on picking on the period. Okay, so what does this mean? That means that the period itself can be the answer. So that's why I didn't want to do it this way, is because it's just because I have to consider this, but I guess I have to anyway. So if this is equal to k exactly, then we can return the period, I believe. Yeah. Okay, maybe we're off by 1, but let's take a look real quick to see if I mean, maybe we're off by 1, but okay, so if no, yeah, because if the right side has exactly k element, then the period is not the answer. It is actually, if this is k minus 1, then the k, I forget, is 1 index, that's why. Okay, so that means that this has to be this, otherwise it just kind of goes weird. All right, am I confident about this? To be honest, I say like 70%. So let's give it a quick submit. Ooh, apparently 7 was high because this is not even close to these answers. Unless I mixed something up. Why am I returning a 1? Oh no, that is just like really wrong, right? So let's take a look. Oh, I didn't subtract stuff. No, that's fine. Oh, no, I have to subtract stuff because now that we don't consider the period, every time we take a chunk, we have to subtract one number. And this is the length of the right plus 1. What? Oh, this is 2. I thought I just copied. Alright, I mean, now that we got the wrong answer again, but yeah. Let's think about this for a second. The 1 index is throwing me off for sure, to be honest, because I think this is... Okay, let's actually then, in that case, just make it 0 index. I think that just kind of confused me a little bit. So then now I was a little bit off. I think now maybe it should be good. Knock on wood. Nope, still not good. Why would 1 is not even close though. 2. So 2, the period is 7, so everything is on the left. So then now... Oh, this still needs to be -1 because the period is not part of it. Yeah, okay. there we go. And this time I'm more confident, but let's kind of give it a spin. Okay, there you go. As you can see, it uses a lot of time because a lot of the things that we do is just not very cheap. I think it's just all the allocation of memory, to be honest. I think the way that I did it is a little bit wonky, but especially in the worst case, the time is actually not from time per se. No, oh, maybe I said that wrong. I think I actually did this very. I thought in the worst case it's linear. I'm wrong. In the worst case it's n squared, isn't it? Which is why, the runtime is so terrible. Yeah, this is terrible. So, I mean, I was a little bit lazy about my period, and obviously, even in the input that they show us on this one, it is actually one of the worst case because it's n squared. Actually, I'm surprised it didn't time out. So that is because the period choice, and this period choice is just lazy. So I think another way to think about this is actually, right? And then here, instead, it should be, I forget how to Python run. Like, you could add randomness to it and it will automatically make this much faster. Wait, let's see, random.went into something? I always forget. Okay, random.went int from, well, we want to look from current, so from 0 to length of current minus 1. I think it's and this changes to current thing. Yeah, there we go. I knew that I changed something. And now we're not returning this, we're returning current or period. Is this inclusive? Let me double check that real quick. Now I'm super not confident. Both include. Oh, okay, so it is inclusive. That's very weird. It's very inconsistent with a lot of things in Python. That's why I'm surprised, to be honest. But yeah, let's kind of see if the running time. I mean, running time should improve because, as you can see, because it's just very hard to generate a case for it. I imagine it's very obvious to generate a case for the other one. But yeah, I think I was just being sloppy, and it's been a while. I thought it was. No, yeah, it was definitely n squared. Now, in the worst case, it'll be still linear, but is it? No, I mean, obviously the worst case is still n squared, but I'm thinking about the average case. I don't know anymore. That's all I have, though. Maybe I'm in too much pain today, so yeah. But I think I mean, today we've been trying to just do something new, trying to do something funky. The first iteration of these things are always going to be a mess because, I don't know, you still play around. There's a little bit of experimentation and exploration. And yeah, even me, been doing this for decades. I still have time to, learn new things. So that's kind of nice. But I would say, if you must, probably the answer that they're looking for is the nlog k one with a heap. Do the heapify and then do log k of them. So yeah. Or the other thing of kind of just keeping, so yeah, you could heapify it and then do log k of them, and that'll be all of n log k time, but it'll be all of n space. You can actually reduce it to all of k space by just using a heap and then just using a min heap instead, right? Cool. Yeah, that's all I have for this one. Let me know what you think. Have a great weekend, everybody, or a great start of the week, everybody. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.